As the world makes its steady move towards integrating AI into their society, those that may not be so tech-savvy may appreciate learning more about AI and their agents. Unfortunately, some of the material we have to get to know more about these things are too basic or too elaborate to give us the information we need to get more familiar with AI. Luckily, we have you guys covered. Today, the guys who are looking to learn more about AI, especially those who have zero technical knowledge but use AI tools regularly, we have everything you need to learn about AI. Join us as we take a dive into AI and AI agents. Large language models, LLM. The first thing you may want to learn about AI and their AI agents is to learn about LLMs. Already, you guys may know more about popular AI out there. We're talking about chatbots such as ChatGPT, Google's Gemini, and Claude. These tools are known to be built on top of large language models. For starters, they are great at generating and editing text for the users. To get things going, humans such as you and I log on to tools such as this so that we provide input to the LLM. Once the LLM gets the input, it goes on to produce an output that is based on its training data. Let's take a look at an example, shall we? You can test any LLM of your choice. We are going to ask ChatGPT to draft an email requesting a coffee chat with a friend. To get this, you'd find that our prompt is our input, and the resulting email that is better than anything we can come up with these days is the output. That seems simple enough, right? Let's take things up a notch by asking ChatGPT when my next coffee chat is. Now, even before we get the response, we know that we are getting nothing because we know that ChatGPT doesn't have the information to know the answer. This situation lets us know two main things about LLMs. For starters, although LLMs are trained with a massive amount of data, the reality is that they still have their limitations when it comes to knowledge of proprietary information such as our personal information or internal company data. The next thing that such a situation tells us about LLMs is that LLMs are passive. Looking at how they work, they are designed to wait for our prompt before they respond. We need to keep these features in mind as we learn more about AI or AI workflows. Let's look at a situation where as a person, so I tell the LLM, every time I ask about a personal event, perform a search query, and fetch data from my Google Calendar before providing a response. In such a situation, if I ask the LLM for some information going forward, it would be able to give the correct answer because it will have the ability to go into my Google Calendar so that it can get the required info. However, it gets interesting if you follow your prompt by asking what the weather would be like on that day. Now, the LM will have a problem because it has been instructed to search my Google Calendar. Don't know about you guys, but I don't think that Google Calendar has any information about the weather. This, in essence, is how AI workflows work. Considering the issues that we just highlighted, we can see how LLMs can only follow predefined paths set by humans. We can take things a bit further by adding more steps to our workflow. We can do this by allowing the LLM to access the weather by mankind using an API. We can take things even further by using a text-to-audio to tell us the answer. This could make things a lot more convenient for the user. That said, we must let you guys know that no matter how many steps you add to a workflow, it will still be just an AI workflow. AI agents. As a human user, you'd find that as a human, think about the best approach to get the most out of your LLM before making use of the appropriate tools to get the best output. We find that for your AI workflow to become an AI agent, your role as the human decision maker must be replaced by an LLM user. To make it simpler, we find that the AI agent must be able to reason. Another feature of this AI agent is that it must be able to do things by making use of these tools. This is perhaps why you'd find that the most common configuration for AI agents is the React framework. After all, as we have hinted at earlier on, all AI agents must reason and act. So React. The third thing that we need to know about these AI agents is their ability to iterate. Think about the process of manually rewriting a prompt to make a LinkedIn post funnier. In that situation, as the human, you would properly have to repeat this iterative process a few times so that we can get something that you as the user would be satisfied with. Well, you may not have to worry about such things anymore because ideally, your AI agent would be able to do the same thing autonomously. Just look at this process as another example of the iterative process. After drafting a version of your LinkedIn post, you may want to make sure that it's actually good, right? To do this, you can add another step so that you can make sure that an LLM will critique the post based on LinkedIn best practices. Repeat this until such best practices criteria are all met. Once this is done, we will get the final output that will satisfy the user. Real-world AI agent. Let's take a minute to take a look at a real-world example of an AI agent. Let's take a look at what Mr. Andrew has for us. A prominent figure in the world of AI, he actually came up with this demo website that shows us how an AI agent works. Once the demo gets a prompt, it enters the AI vision agent in the background. Said vision agent first reasons what your prompt is attempting to visualize. Let's enter a prompt saying footballer. The vision agent then attempts to visualize what a footballer looks like with several examples. To make things even better, we can see how the vision agent will look at clips of footballers as it attempts to identify what it thinks a footballer is. It will then index the clip before giving the clip back to the user. While this may not look so impressive, we must keep in mind that an AI agent did that, not a human being. That we got our output without a human having to review the footage as they identified the footballer while adding relevant tags. Looking at the features, we can tell that the programming is more technical and more complicated than what we see in the front end of things. Well, that is what makes this demo so important. Thanks to it, we can see that the average user just wants a simple app that just works, instead of one that is all flash without substance. We don't need to know exactly what goes on at the back end. All we need to see is that it is able to carry out what it is built for. All in all, we can see that there are 3 levels when it comes to understanding AI and AI agents. First, we have the large language models, aka the LLMs. Thanks to these LLMs, we have the technology to get the outputs we desire with just our prompts or input. On the second level, we have AI workflows that give LLMs a predefined path that would help us give us outputs after retrieving information from external sources. Here we find that the human may program paths for the LLM to follow. That is why the third level is so important, because here, when the AI agent receives the prompt, the LLM in charge of reasoning does so in order to determine the best way to achieve the goals set out by the user. It also takes actions using tools so that it can produce an interim result. Following this, it observes the interim result before it decides if it needs to carry out any iterations on its way to produce a final output that achieves the initial goal. Here it is important that the LLM is the key decision maker in the workflow, not the human. With that, we have that AI agent that will help us make the world easier in the years to come.